All right, so inverse trig ratios. This is the exact same thing from yesterday, but instead of finding the sides, we're going to find the missing angles. You notice that yesterday we always had an x on the side. Now we have an x where the reference angle is. So we need to find it. So we're doing the inverse of what we were doing yesterday. Remember, we have SOHCAHTOA. And that's going to be the thing that you really need to remember here to determine which one you use. So we're doing the same thing as yesterday when it comes to our reference angle, right? So then we label our hypotenuse, adjacent, and that means 15 has to be opposite. So the two things they gave us are O and H, and that means we are going to use sine. So the sine of theta equals opposite over hypotenuse. I still want you to do this today, just because we only have one day of working with it. You know, in the future, you should get this and not have to write that step. But now it's the sine of x degrees equals the opposite 15 over the hypotenuse 24. So here's what's happening. Right here, this x is our angles, right? And these are our sides. Well, anytime you're trying to solve for something and solve for its inverse, what you do is you switch the two variables. So if I gave you this example, y equals 2x, you switch the two variables, x and y. You switch their places. And then you solve for y again. So we would divide by 2, like that, and y would be 1/2 x. So pretty much what I want you to focus on there is this switch of the two places. X and y are two different variables. So what we're going to do with these angles and sides is we're going to switch them in their places just like we did over here. So what our next step will be is the sine inverse, in other words, the inverse sine of 15 over 24 will equal x, our angle. So you have to do inverse sine so that your calculator knows, hey, I'm giving you sides inside our parentheses here, and I want you to give me the angle. If you don't do inverse sine, this is not going to work. Now, the way you do this is instead of just clicking the sine button, you do second sine, and it will pop up as sine with a -1 up top. That is called inverse sine. Again, make sure your calculator is in degree mode like we had yesterday. If it's not, you're going to get some crazy answers that are not going to look like what I have. So our final answer, and we're going to round that to the nearest tenth, is 38.7 degrees. For number 2, all right, same thing. Reference angle. Here's our hypotenuse, adjacent, and opposite. So the two things they gave us here are A and H. So that is going to be cosine. Cosine of theta equals adjacent over hypotenuse. So we'll have cosine of x degrees, and that will equal adjacent 8 over hypotenuse 11. Now our next step is to use the inverse cosine and switch their places. Okay, so that's the only step that we're changing from yesterday. We are doing the inverse trig ratio and then switching their places. So then the inverse cosine of 8/11 will be 43.3 degrees. You can also use a little bit of common sense here, right? So if this triangle is a right triangle, then all of these answers have to be less than 90, right? If there's already 90 there and it adds up to 180, every single one of our answers has to be less than 90, but obviously still greater than 0. So if you have an answer that's not in between 0 and 90, you know you did something wrong. You probably just didn't do the inverse trig function. You just did the normal one. All right, number 3. So we have our reference angle. Here's our hypotenuse. Here's our adjacent. Remember that reference angle always touches the hypotenuse and the adjacent. So that means the opposite will be the last one. So here we have opposite and adjacent. That's going to be tangent. So the tangent of x degrees equals opposite 20 over adjacent 37. We'll do inverse tangent. And once you type that in, that will give you 28.4 degrees. All right, I'll do two more. I'll do 5 and 6. So here's our reference angle. That reference angle always touches two sides, the hypotenuse and the adjacent. So that means 40 has got to be the opposite. So if we have O and H, that's going to be sine. Sine of x degrees equals 40 over 41. We'll do the inverse sine, and that will equal our angle, which here will be 77.3 degrees. So really not too bad stuff. Just getting a lot of repetition in so that you guys will understand it and get it down. There's your hypotenuse, there's your adjacent and opposite. They gave us adjacent and opposite, so that's going to be tangent. Tangent of x degrees equals opposite over adjacent, 7 over 5. Inverse tangent, because we're looking for the angle, not the sides. And once you type that in, that will give you 54.5 degrees. Again, if you're not getting that, make sure that you are checking to see whether you use the inverse function and whether your calculator is in degree mode. You click on mode, go down to where it says degrees, and make sure that that is highlighted. All right, so as a little review, we're going to find sides and angles here and do a couple of word problems. So this is a side, so we're not going to use inverse trig like we just learned. We're just going to use normal trig, just like what we did yesterday. So, and you'll kind of get this. You don't have to immediately identify whether you're using inverse or not. If you just set up the equation, it should be pretty clear. So we have hypotenuse, adjacent, and opposite. So we're using tangent here. Tangent of theta equals the opposite over adjacent. So those three things, theta, opposite, and adjacent, are the three things that you're going to be plugging in for. So it's tangent of 39 degrees equals opposite 11 over adjacent x. So immediately here you know that we're not using inverse like we did before because the x is on the sides. But you do need to remember this trick that we can just switch these. All right, so that'll be x equals 11 over tangent of 39, just normal tangent, not inverse, and that will give you 13.6. Now you notice that everything I put above has degrees, right? All of our final answers have degrees. These will not, because this is a side. Okay, so if you put 13.6 degrees on this and I have a quiz or something like that, you would not get full credit because it kind of shows me that you're not, that you don't know what you're talking about. Yeah, so it's just like in normal terms. You know, if I asked you, hey, you know, how many days does it take to complete this? And you give me, oh, it takes such and such hours. You know, well, that's not what I asked for. So be sure that your answer matches up with what the question was asking for. Maybe that's not the best example, but that's okay. So hypotenuse and adjacent, opposite is blank. That means we're going to use cosine of 46 degrees equals adjacent over hypotenuse. So here all we need to do is just multiply both sides by 28, and that will cancel out. So 28 times the cosine of 46 will be 19.5.